Hey, this is OXDF, and today we're looking at the Advent of Code 2015, Day 16, Aunt Sue, and we're doing this to learn Rust. Let's go ahead and jump in. So basically, we got a gift from Aunt Sue, and we have 500 Aunt Sues. And there's some crime scene analysis thing that takes a measurement off the gift, and the important thing to know is the one we want to find has these statistics. So it has 3 children, 7 cats, etc. So then we have this list. Our puzzle input is going to be this list of Aunt Sues. And each of them has 3 items about it. And just because one Aunt Sue doesn't, this Aunt Sue 18 doesn't have any cats, she could have cats, she might not, we don't know. So we need to go through all these Aunt Sues, find the one that matches all 3 of their things to this list, and we'll be done. At least with part 1. In case this is your first one of these, I solved a lot, I think 17 or 18 of these challenges several years ago in Python, so I'm going back to doing them now to learn Rust. So that's why we already have the puzzle solved. But let's go ahead and jump over. I'll do my GenDay script here to get day 16 running. I cover this in detail on day 0, but the short version is it pulls input.txt for me and it gives me this template to start working off of. And so let's see. I might need a quick reload on my extension. All right, it's up and going. Let's go ahead and get going here. So the first thing I'm going to do is create a Sue object. So I'll do struct Sue, and a Sue will have an ID, which will be like a usize. So it's going to tell us what number Sue is, and it's going to have a props, which will be a hash map. And that hash map is going to take a string, like the name of the thing or the item, and it's going to return a usize, the number. And that is our Sue. Sue's looking good there. We are going to need to, let's see, we need to use std collections hash map. Okay, we're good there. Yeah, no, let's see. So that's good. We have a Sue. Next thing we need to be able to do is we need to be able to read a Sue from a string. We could just a way to parse a string into a Sue. So we'll do from string like that for Sue, and that'll have the from function, which takes a string, which we'll call s, and it returns a Sue. And so now the first thing we need to do, let's go ahead and we'll do let tox equals s.split on space, because everything here, if we look up here, everything is space. We can split on space to get a bunch of tokens. And we'll do that, and then we can do dot collect, and that'll give us a vector of things. That looks good. I wonder if we could do, yeah, that'll work for now. Okay, so the next thing we need to do is make a Sue for this object. So we'll make let mut Sue equals a Sue. And that Sue is going to have ID, and that'll be tox1. Because if we look at, I'm going to go ahead and grab a Sue here. So we have it over in our code. So we'll add it right here. Okay, so now we have a tox1, and that's going to be this right here, this 2. We need to get rid of that trim end matches on the colon. I don't know if I should do that like that for a character. And then we can parse that. Not parse. Oh, yeah. ID is a size. Yeah. So parse that and unwrap. And we should have Sue's. I don't need the semicolon there. That's our Sue ID. And now our props is going to be a hash map, not a hash map new. So we're making a new hash map. And we will semicolon here, and at the bottom we will return Sue. Okay, so now we're going to return kind of an empty Sue. Let's see what's wrong with tox here. We're going to need a type. Okay, that's fine. We can give that a vec of, is it string? I think it's string. That. Sweet. Okay, so now we have that. Now we need to go through and add in all our properties, right? So we'll do let. What I'm going to do is I'm going to try to do this in a generic way so that it can take all of these inputs look to be 3 properties, but let's make it generic so it can take any amount. So we'll say let mut I equals 2. And then we can say while I is less than talks.len. And what this is going to let us do here is now we can say let item equals talks dot I. So now we start with 2, so we have 0, 1, 2 perfumes. Okay, so we need to strip off that colon again. So we'll do trim end matches on the colon like that. Oops, extra. And then we can toString that, and that should be good. We now have an item. Now we can do let num equals talks, and now this will be I plus 1. That, and now this time we need to trim this comma off. So we'll do trim end matches comma, and this time we'll parse it to make it an integer, and we'll unwrap, get our result, and that looks happy. So now we can just do su.prop.insert item comma num. And the last thing we need to do is iterate our I plus equals 2. Now we jump ahead. And that looks good. What are we missing here? So we will cargo run this. And what are we unhappy about? Let's see. Value of type string cannot come from an item of strings. Oh, so maybe we need to let's see, what if we make this like that? Does that make everything happy? It does. Okay. So now we can create sus from strings. So let's come down here and start designing what our main is going to look like. So we're going to have this data, which is all of our different lines. I'm going to say let default su string equals, and this is going to be, I'm going to grab this from the website. It's going to be this. We will paste this right here, like that, and I'm going to now hopefully quickly put together this like this. Whoa, we lost something there. Probably if we were in Vim right now, I could do this much faster. Oops, I lost the V. We're getting close here. Goldfish. Okay, trees. Oops, lost the C. Cars. Okay, perfume. So we have this really long string, but we have our default su string, and so now we can say let we'll call the main su. Su equals so su is a su equals default su string dot into into searcher, just into, like that. And the one other thing we need to do is we need to put a number at the front here. If we look at our example up here, we have su and then a number. So we need to add one in here. We're going to just, since the input starts clearly at 1, we'll make our su 0. So now we have su created out of that default string. If we run up here, we can probably default debug print this and see what it looks like. Do we implement? We did not. So let's see, come up here, pound derive debug, like that. And now let's see if that runs and prints us a su. It does. We got a su with all of our stuff read in. So perfect. Okay, so now what we're going to do is we're going to come over here and we're going to say for line in data.lines. It's a very common thing in these advent of codes. Now we're going to say let maybe su equals, we got a su equals line.into, like that. And now we've got a new su. And now we can do something like if su dot matches, which we haven't defined yet, but we're going to, maybe Sue. And then we will print line part 1 like this. And then we'll do maybe Sue.id. And now see, we can get rid of this right here because we've already got part 1 printing. And that is all we need to do. We're just going to loop over it. And now we just need to define our matches function, right? So what does it mean for a Sue to match another Sue? So we'll come up here and we'll say impl Sue. And now we'll say fn matches. Now this is going to take self, and it's going to take Sue, another Sue, and it's going to return a bool. So what we're going to do is we're going to say for prop in, and what we need to do is make sure we go over the candidate Sue. So this will be s.prop dot, I guess, keys. Now let's do iter. We can do s.prop.iter. And this now is going to be a little bit broken. We can say this will be both the prop num, like that. Let's see, we're missing something here. What do we? Let's. It's not, because there's no return. It's unhappy with us. So let's get that. If we can get the, because that's not props. And here we go. So now we're getting a prop will be our string and our size. So we're getting both. And now we can say if self.props.get prop. So if we go to our self and get the 1, not equal to num, return false. And then otherwise, if we make it through all of the properties in the candidate Sue and they're always equal, then we return true. So what do we not like here? Expected an option, so we got to unwrap here. I'm sure there's more intentional ways to handle this. I'm doing things like the equivalent of like except in Python without catching certain exceptions, but we're just going to go with it. So now we have our matching function. I think let's not, I don't want to jinx it, but let's cargo run. Oh, we got an error. Let's see. Maybe Sue is borrowed version of maybe Sue. So maybe we need to clone this. We're probably gonna have to go up here and implement or derive, clone. And we definitely don't need this up here. Let's get rid of that. I don't know why that got added. Now we run. We get 40, and I believe that was our answer. It was. Sweet. Okay, so part 2, we learn that something is slightly wrong, that actually the cats and trees readings indicate that they are greater than that many, that the real Sue has greater than that many, and the Pomeranians and goldfish indicate there's fewer than, and then the implication here is the rest of them still mean equal. So, so we just need to slightly change our validates function, our matches function. So we will come here and we will grab this and we will come here and print matches 2. And so this time we're gonna start the exact same. We're gonna loop over our candidate Sue's possibilities here. But this time we're gonna start with if, and we'll say cats, and I believe it was trees, cats and trees dot contains prop. I'm sure that's not going to work, but we'll leave it there and let the errors tell us where to fix it. Save. Let's see, what do we got here? Expected reference to a string. So we found a string, so we need to do this dot as string. Will that work? Beautiful. Okay. So if it's cats or trees, then we're doing a different test. We're going to do if self.props.get prop dot unwrap, just like above. And this time we're going to say if that's greater than or equal to num, that's what's going to be a failure case, then we're going to return false. Now we can say else if, and now this time we have to do Pomeranian, let's see. Pomeranians and goldfish. So put this here. Quick tinker. So there's else if that contains and we want it to look just like before, prop as string. And this time we want to do the opposite. So we're just going to do grab this, paste it right there. If self props unwrapped, and this time we'll do grade it like that. So now we have that one, and then we have to handle the still have to handle the base case, else, and we come in here and we tab that, and we tab that, and we break there. It feels very unlikely that I would get this right on the first try, but let's give it a try. So basically all we did was just had to change slightly our matches function here to handle these trees and Pomeranians and goldfish and cats differences. So now down here in our loop, we can get rid of you. We can say, grab this whole thing, and if Sue.matches to, maybe Sue clone, print maybe Sue ID. Any issues? All right, let's run it. 241. 241. Awesome. Not as bad as some of the ones I've been pacing lately. So thanks for sticking around to the end. Hopefully you enjoyed, and we'll talk to you next time. Thanks. Bye.